f of x equal to minus 1 when minus 2 is less than or equal to x less than 0, and x square minus 1 when x is between 0 and 2. And g of x is absolute value of f of x plus f of absolute value of x. Then we have to find whether this function, this g, is continuous, differentiable, etc., etc. Okay, let us try to create this function first, g of x first. So we have two parts, absolute value of f of x. So absolute value of f of x. That means whenever f of x is negative, we have to make it positive. When is f of x negative? Firstly, between minus 2 and 0, it is negative. So absolute value of f of x will be 1, because absolute value of minus 1 is 1. Between minus 2 less than or equal to x less than 0. So far so good. Then what about x square minus 1? X square minus 1 is negative when x less than 1. Right, we are concerned about 0 to 2. And this is negative and positive when x greater than 1. Right. So x square minus 1 is negative. So absolute value of this is minus of x square minus 1. Minus of x square minus 1, which is nothing but 1 minus x square when 0 less than or equal to x less than 1. Right, and 1 less than or equal to x less than 2, it's anyway positive, so it is x square minus 1. Right, so it is 1 when minus 2 less than or equal to x less than 0, 1 minus x square between 0 and 1, and between 1 and 2 it is x square minus 1. This is about absolute value of f of x. Now what about f of absolute value of x? F of absolute value of x. F of absolute value of x is f of, even if x is negative, right? So for example, f of absolute value of minus 1. What does that mean? This is equal to f of 1 only. So this part we can in fact ignore. So even if it is some negative number, ultimately it will take this value only. Right, f of absolute value of minus 1 is equal to f of 1, then that is nothing but x square minus 1, right? We have to take this x square minus 1 only. Right, so what does that mean? Whatever is positive, that same thing will get reflected on the left side also. Right, so whatever minus 1 is there will make, so same thing, whatever the value of 1 is there, we will take the same value at minus 1 also. Right, what does that mean? F of minus 1, absolute value of minus 1, what does that mean? F of absolute value of minus 1 means f of 1. That means if f of 1 is this point, then minus 1 also will get the same point. So this graph is actually reflection of this, whatever is on the right side. So absolute f of absolute value of x is actually equal to f of absolute value of x is actually equal to x square minus 1 between all the time, right? Between minus 2 to 2, right? So that is our function now. F of x we have defined. It is 1 between minus 2 and 0. It is 1 minus x square between 0 and 1. X square minus 1 between 1 and 2. And f of absolute value of x is x square minus 1 all the time. Right. Now we want to do the sum of these two. Right. We have now sum of these two is actually sum of the respective ones. Minus 2 to 0. It is minus 2 to 0. What is our g of x? This plus this. Right. So g of x is this one plus this one between minus 2 to 0. Right, x square minus 1 plus 1, which is equal to x square. And between 0 and 1, this plus this again. 1 minus x square minus 1, both will cancel, it is 0. Right. And between 1 and 2, it is x square minus 1, x square minus 1, 2 times x square minus 1. Right. So we have calculated what is our g of x. Now let us try to draw the graph of g of x between minus 2 and 0. It is x square. So x square, the graph of x square is like this, right? It's a parabola. So between minus 2 and 0, we are taking this part. That is this part. Right. Now, between 1 and 0, 0 and 1, it is 0. So that is this part. And after between 1 and 2, it is 2 into x square minus 1. What is x square minus 1? It is x square shifted 1 unit downwards. That is this. Right. It is shifted 1 unit downwards. So, and obviously this is 0 when x equal to 1, right? At this point it is 0, and 2 times of x square minus 1. 2 times of x square minus 1 is the same graph stretched 2 times, right? So it is stretched 2 times. That means if it is 1 here, if x square was 1, then 2x square would have been 2. Right, x square minus 1, it is stretched 2 times. So that's why the slope would be steeper than the x square graph. So if this one was stretched by 2 times, right? Because if this was 1, this becomes 2. If this is 2, this becomes 4, like this. So clearly, this is x square graph, this is 0, and this is 2 times x square minus 1. You can clearly see it is continuous everywhere, definitely. But what about the differentiability? So it is not continuous is definitely wrong, right? And for differentiability, we have to match the slopes from left side of and right side, right? So clearly at this point, the slope, one side the slope is 0, another side, what is the slope? The slope is differential of this is that is 4x, right? 4. The slope is 4. So here at point 1, it is clearly not differentiable. So what about this point? This point, right side the slope is 0, but left side also the slope is 0, right? X square, the slope of x square. What is slope of x square? It is differential of d by dx of x square, which is nothing but 2x. When x equal to 0, the slope is actually equal to 0. So at this point, this graph, left side and right side, both sides, the slope is actually equal to 0. So at 0, it is differentiable. So at 0, it is differentiable. At 1, it is not differentiable. So not differentiable at 1 point. This is wrong. This is wrong. It is not differentiable at 1 point. Right, guys?